Hello, and welcome to one more module of this machine learning course by me, Dr. David Garcia. Today we will speak about module 3, linear algebra for artificial intelligence. This module is part of the beginner level, and in particular, we will speak about vectors and matrices, matrix operations and properties, eigenvalues and eigenvalues, and lastly, singular value decomposition. First, let's introduce why vectors and matrices are important to machine learning. When we are training a neural network, actually we have a lot of information, data or numbers propagating inside of a complex neural network. And there are some mathematical operations that create this training, this knowledge learning. This mathematically it's a way of looking for a minimum or a maximum. So that's the most important point. And this information that is moving through the network, it's represented as vectors and matrices. As you can see here, easy representation. There are several dimensions to data. You can have a scalar, a normal number. You can have a vector, which is several numbers in the same direction, either vertically or horizontally. Then you can have a matrix, which is a square or a rectangle. And then more complex than that, you can have a tensor. This is quite common in machine learning for training networks. That's why Google, for example, created TensorFlow, a very famous machine learning library. And it's interesting to mention that here we are making more and more general subsets. So, for example, a scalar is a particular type of vector, a vector is a particular type of matrix, and matrix is a particular type of tensor. It's just a really simple version of the next group. Let's speak about how vectors are often used in machine learning. This is, as I said, it usually represents a feature or a data point. And one example is if you have a data set of houses and each house is described by the features like square footage, number of bedrooms, price, you can represent all of this, all of the house by just one vector, which has these three components: square footage, number of bedrooms, and price. Then let's speak about matrices. A matrix is a dimensional array of numbers consisting of rows and columns. And in machine learning, it's common to use them to represent data sets, transformations, and operations on data. In data sets, each row of the matrix can represent an individual data point, and each column can represent a specific feature. In the context of machine learning, a dataset can be, as I said before. So going back to the example that we had before, if we have a list of houses, each house will be a vector. But if we want to represent all the houses available in one neighborhood, we can build a matrix which has all of this. So each row of the matrix, it can be seen as a vector, and it's a house, but the whole matrix will be the neighborhood, the block of apartments, well, so on. That's the idea. Now let's speak about matrix operations.